Good afternoon, dear learners. Today we are going to study about database management systems. I am Natasha Yadav, consultant ICT, and today I am going to teach you about database management systems from senior secondary computer science course. So let's start. So let us just have a brief review of what all we are going to discuss today. Firstly, we are going to define a database, that we are going to understand what is a database. Then we are going to design a simple database. We will see that how do we create a database and how do we create table using SQL, and then we are going to write and execute some SQL commands. So let us first understand what is a database. A database is an organized collection of data. From daily life, we can take many examples of simple databases. For example, if you see the index of a book, the telephone directory, the ads which are classified in a newspaper, all these are simple databases which we can see are in our daily lives. More complex examples may include registers containing data of students in a school, data of employees in a big organization, etc. You must have seen, whenever in a school, whenever a teacher takes attendance in an attendance register, the serial number, the roll number, the name of the student, father's name, etc. The list is there. That sort of data which is present in form of a list is a database. So these are the examples of a complex database. Now let us understand that what is actually the need of a computerized database, that why is it necessary that we should have a database in a computerized form rather than a manual form. So manual form, I just told you, just like a attendance register in a school. So we will see what are the advantages of a computerized database over a manual database. So databases can be organized manually or using computers. When the databases are organized manually, some problems creep in frequently. So what kind of problems do we face when we create a database manually? First is redundancy. So having multiple copies of the same data. For example, a student's name is written in office records as well as in class teacher's record. So this redundancy leads to inconsistency. So see now, whenever there is a student enrolled in a school, the record of the student is there in the class teacher's attendance file. It is also there in the office file. So and similarly, it can also be with some lab files, in some sports files. So a same data is maintained at various places. So that's why we say that the multiple copies of data are produced in manual database. The second problem which we face is inconsistency. So having multiple mismatching copies for the same data. If a student section changes from A to B, this change is recorded only in the class teacher's register but not in office registers. Now suppose Ram is a student, he is currently in 10th A, we can say. His record is there with the class teacher, his record is there in the office, and his record is also there in the let's say in the sports file. There's a file which also have the students list according to the sports which they have taken as their hobby. So now suppose the student changes its section from 10th A to 10th B. Now the class teacher has changed this record in the attendance register, but in the office files and in the sports teacher's file, the data remains the same. So this leads to inconsistency. There are mismatching copies of the same data everywhere. So the second problem which we face in manual database is inconsistency. The third problem which we face in manual database is loss of integrity. Data integrity also includes having valid data only. For example, if there are 4 sections A, B, C, D of a class, but a student's section is recorded as something other than these, then it is an example of loss of integrity. Suppose by mistake the section has been mentioned as F, but such a section does not exist in the school, then this is an example of loss of integrity. I hope you understood what is loss of integrity. Now the fourth problem which we encounter is data insecurity. Manual databases can be secured physically but cannot be secured against unauthentic data alterations. So suppose the attendance register which a teacher maintains is kept in a class cupboard or somewhere. So whenever in the absence of teacher, it can be accessed by anyone, and anyone can make any changes, any unauthentic changes in the register. So but this is not the case with the computerized database. In the computerized database, a database is secured from any unauthentic alteration. It cannot reach any unsafe hands. So these were the problems which we face with the manual databases. Now what is a need of computerized database? Computerized database provides centralized control of its operational data. Thus, with the help of a computerized database, redundancy is controlled, inconsistency can be avoided, integrity of data is maintained, data can be shared very easily when it is in the computerized database. Suppose the simplest form where we can store a database in computer is in form of an Excel sheet, and you want to share it with 100 of people. So within just clicks you can share that Excel sheet with anyone you want. So the data can be shared very easily when it is in computerized form. Security restrictions can be applied. So whenever you are sharing your database with anyone, you can give them specific permissions that what kind of alteration you require from that person. Suppose you want to give only viewing rights to anyone, then you can give only view rights. Suppose you want a particular admin to be only one admin to be responsible for editing the database and rest of the people of the organization just to view. So we can give those appropriate rights to anyone you want. So security restrictions can be applied to a computerized database. Now let us understand some basic terminologies about database management system. So what is a database management system? It is a software that allows us to manage the computerized databases. So now we have understood what is a computerized database. Now there are softwares which are just made to manage those computerized database. Those softwares are known as database management systems. Now, what is a relational database management system? It is a DBMS based on the relational model. The relational model was introduced by E.F. Code. Now, what is a relational database? So, a relational database is a database in which data is organized in two-dimensional tables, also called relations. We also call those two-dimensional tables as relations. A table consists of rows. Rows we also call rows as tuples or records, and columns also called attributes or fields. So what is a relational database? You can imagine a relational database as a table in which the data is organized in form of rows and columns. So that was all about relational database. Now what is a schema? Schema refers to the organization of data, or you can say it is the skeleton structure that represents the logical flow of the entire database. I have taken an example from a table. So the table name is student. Now this is the particular schema of that database at a particular time. So what are the different attributes we can see in this? Student ID, name, address. So this is an example of a schema. Now let us understand what is an entity in a database. An entity is a person or object which can be either physical object or a logical object, for which we need to store data in a database. Suppose in a school, suppose you are maintaining the database for a school, then in a school the entities can be a student, a teacher, a course. In a library, an entity can be a book, a member, a book supplier, etc. So an entity can be anything. It can be a person, it can be an object, it can be anything. Then let's come to relation. So a relation or a table is a collection of data corresponding to the same kinds of entities in a database. A relation may contain data of all the books in a library or data of all the items in a shop, etc. So a database contains one or more than one relation. So there are many tables which can exist in a database at a particular time. So a relation is something which combines more than one table. It can be 2 tables or it can be 3 tables based on some relationship. These relationships can be of many forms. It can be one to one, it can be one to many, it can be many to many, which we are going to understand later. So now let us understand what is a tuple. So as I already told you before, a tuple is also known as a row or a record. A tuple corresponds to a row of a relation. A tuple contains data corresponding to any entity. The number of tuples in a relation is called the cardinality of the relation. So what is basically a tuple? It is a row, and the number of rows in a table defines the cardinality of a relation. Suppose a relation has 10 rows and somebody asks that what is the cardinality of this relation, then we will say the cardinality of this relation is 10, and it is actually the data corresponding to any particular entity at a time. Now what is an attribute? An attribute corresponds to a column in a relation. The number of attributes, columns in a relation is called its degree. Now this is very important to understand that what is the difference between the cardinality of a relation and what is the difference between cardinality of a relation and degree of a relation. Cardinality refers to the number of rows in a relation, whereas attribute refers to number of columns in a relation. And what are the columns? They are the attributes. So this is the difference between cardinality and degree of a relation. Now domain. A domain of a column is a pool of values from which that column draws its actual values. For example, domain of the column roll number may be an integer from 1 to 50. So now let us understand this. So this is a table. This table has 5 attributes, 5 columns. What are those columns? This is representing the data for a student. So the 5 attributes are SID, so which is representing the student ID, SName, which is representing the student name, SAge, which is representing the age of the student, SClass, and SSection, so the student's class and student's section. So these are the 5 different attributes, and then we can see there are 5 rows also. So there are 5 different IDs: 1101, 1102, 1103, 1104, and 1105. So these are the different tuples which we can identify by using SID or any other attribute which you want. So these are the different 5 tuples, and there are 5 different attributes also, and this whole thing together is a table which is also known as a relation. Now let us understand what is a key. A column or a combination of column which can be used to identify a row in a table is called its key. So as we were discussing in the last diagram, I told you that we can identify a particular row with the help of SID. So we can consider that SID to be a key which is used to identify a particular row in that table. In general, any column or any combination of column in a table is a key. It is not necessary that only one particular column has to be a key. We can also consider the combination of various attributes to be a key together. Now then, what is a primary key? The group of one or more columns used to uniquely identify each row of a relation is called its primary key. Now the primary key is also used to identify the rows uniquely in a relation. For example, in a student table, admission number, SID, which I told you, can be the primary key. A table cannot have more than one primary key. It can only have one primary key. Now a candidate key, a field or a combination of field which can be used as a primary key of a relation is called as a candidate key because it is one of the candidate available to be the primary key of the relation. A table may have multiple candidate keys. For example, in the student table, admission number as well as the combination of class, section, roll number are the candidate keys. So from within different candidate keys, we identify one primary key. So the primary key is the one which is also a candidate key. Then alternate key, a table may have multiple candidate keys. So one of these keys become the primary key of the table. All the remaining candidate keys are called the alternate keys of the relation. Now we are going to discuss about foreign key after a short break.
जीवन ये प्रकाशित करने राहों को आलोकित करने, जीवन ये प्रकाशित करने राहों को आलोकित करने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने, अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने, जीवन ये प्रकाशित करने राहों को आलोकित करने। धन साधन समय की सीमा से विद्यालय जो मुक्त हो, धन साधन समय की सीमा से विद्यालय जो मुक्त हो, कभी पढ़े हम कहीं पढ़े वे विषय की लोच से युक्त हो, कभी पढ़े हम कहीं पढ़े वे विषय की लोच से युक्त हो, मित्रों हम उठे और जागे, मंजिल आने की ध्वनि सुने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने, जीवन ये प्रकाशित करने राहों को आलोकित करने। राष्ट्रीय मुक्त विद्यालय का है द्वार खुला सबकी खातिर, शिक्षा परीक्षा का अवसर एक बार ही क्यों मिलता फिर, शिक्षा परीक्षा का अवसर एक बार ही क्यों मिलता फिर दुनिया में इसके केंद्र बात, कोई मन चाहा केंद्र चुने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने, कोई मन चाहा केंद्र चुने, स्वयं बने,
Welcome back, dear learners. So we were discussing about foreign key. So as I told you, in a database we relate two or more tables with a relation. So what is a foreign key? It is a group of one or more columns in a table which is used to set the relationship of this table with some other table. So when a table is related with other table, it is the foreign key, it is a primary key which acts as a foreign key in the other table. Then Cartesian product. So Cartesian product is taken for two tables obviously. It is a new table which contains the columns of both the given tables. The rows of the new table are obtained by pairing each row of the first table with each row of the second table. Then normalization. Normalization is the process of analyzing the data to be represented and breaking it down into separate tables in accordance with the principle of relational structure. Now, data models. So, there are three types of data models which we are going to discuss: conceptual data model, logical data model and physical data model. Let's understand them in detail one by one. Conceptual data model. So, conceptual data model can be thought of as a bird's eye view of the database. It identifies various entities at the highest level relationship among them. Conceptual data model has many features. It includes important entities and relationships amongst them. No attribute is specified, no primary key is specified. So, let us consider one example. So, the student example only let us take. So, in our example, entities are students, courses, marks, result. So, result are prepared by taking data of student, courses and marks. So, we have displayed it in a conceptual data model. So, this is the very basic general view of the database. Now, let us discuss about logical data model. Logical data model can be thought of as a closer view of the database. In the conceptual model, we look at the entities and their relationships only. In logical data model, we describe the attributes of these entities in as much detail as possible. So, if we discuss our example, the entities students, course, marks and results, and in logical data model, we consider their attributes also, which are as follows. So, the student can have various attributes such as admission number, course code, name, address, subject code, result. Like for all the subject, for many subjects we can have different subject codes, and for the different subjects we can have different result codes also. If we talk about the entity course, course can also have various attributes: course code, course type, course name, eligibility, subject code, maximum marks, pass percentage. So, this again we can have for different subjects whichever are included in a particular course. If we talk about marks, so marks can have admission number, course code, subject code, marks obtained. And now these three entities combined together are used to form the result. So, the result can have the attributes as admission number, course code, subject code, course name, student name, subject name, marks obtained, maximum marks, percentage and result. So, this was about the logical data model, about the conceptual data model. Now, let us come to logical data model. Logical data model has the following features. It includes all entities and relationships among them, and normalization basically occurs at this level. All attributes for each entity are specified. The primary key for each entity is specified. Foreign key, the key identifying the relationship between different entities, is also specified at this data model. Now, physical data model. So, the physical data model represents the actual implementation of the logical data model. A physical data model shows all the table structures including column names, column data types, column constraint, primary key, foreign key and relationship between the tables. So, in our example of school, the physical data model can be represented as follows. So, if we talk about the student entity, we are specifying the attributes, then we are also specifying the data type corresponding to that attribute, and also if it has any special constraint. So, for example, if we consider admission number, we will specify that this is of the data type varchar. We are going to discuss the different data types in a short while. So, the admission number is of varchar type, which is 8-bit long, and then it is also the primary key. So, similarly, now the course code, which is also a varchar, is a foreign key which is referring to the course entity. So, this is how it is different from the previous one, that we are also specifying the data type, the length of the particular attribute and also the special constraint which it is following. if we talk about the course entity, then course code is the primary key of the course entity, and it is also a varchar which was referred by the student entity as a foreign key. If we talk about marks, then it is specifying admission number, which is a varchar and which is a foreign key referring from the student entity. If we talk about course code, again it is a foreign key here which refers to course entity, and if we talk about subject code, this refers to the student entity, and these three together forms the primary key of the table marks. So as I told you, it is not necessary that only one column has to be a primary key, the combination of columns can also be a primary key. So these three columns together here forms the primary key of the table marks, and similarly with result also, three columns are merging together to form the primary key of the table result. Now this was all about the different data models. Now let us discuss about the SQL language. So SQL stands for Structured Query Language. MySQL is an open source free software. It can be downloaded free of cost from and requires no cost for its usage. SQL is a language specifically oriented around the relational databases. It is a non-procedural language and requires us to specify what is to be done. We have to specifically mention what all steps have to be followed. SQL offers us various commands using which we can create and manage the relational databases. We will understand those commands in a short while. So, firstly let's understand the division of these commands. So these commands can be classified into three classes depending on their purpose: data definition language, data manipulation language, and data control language. Let us understand them. So data definition language consists of those commands that create, modify, and remove objects such as the tables, indexes, views, and so on in the database. So that is the data definition language. Now data manipulation language, it consists of those commands that are used to retrieve, manipulate, and update the data present in the table. For this, the data should already exist and then we can manipulate it. So that is the data manipulation language. Then is data control language. It consists of those commands that determine whether a user is permitted to perform a particular action. It gives different authentication permissions to the different users and controls the access to the database. Hence, it is the data control language. SQL is a non-case sensitive language. It means that a command can be entered using uppercase, lowercase letters, or a combination of these two. For SQL, all the lowercase and uppercase remains same. Each command in SQL is terminated by a semicolon. You can write a particular command in as many lines as you want, but the system will consider that to be terminated only when a semicolon appears. So a statement may spread into multiple lines. It will be terminated only when a semicolon appears. Now let us see how do we create a database. So first of all, we have to create the database using the SQL command create database. So we write create, the keyword create has to come, then the keyword database has to come. Now suppose you want to name that database as OS result, then the command will be given as create database OS result and then a semicolon, as every command needs to be terminated by a semicolon. Now once this database is created, it needs to be made active. So how do we make a database active? We do it using the use command. So suppose you want to make active the OS result database, so you will write use OS result. So now the control will come to the OS result database. Now a table is created using the create table command. So how do we create a table? We use the command create table. Then how do we write it? So firstly you write the keyword create table, then we specify the table name which you want to create. Suppose you want to create a table student, so you will write create table student. Then in circular bracket we specify the different columns which we want, because a table is a combination of rows and columns, and the column names are the different attributes which you are giving to that table. So you have to specify those different attributes along with their data type and along with their constraints in circular brackets separated by a comma. So as we have specified column name 1, then its data type, then if you don't want that to be null, so you will specify not null. Then column name 2, data type 2, default null, that means by default it would be null. So similarly, if you want n number of attributes, you have to write all of them, you have to write their data type, and you have to give the constraint which you want to apply, then close the circular bracket and then apply a semicolon. A data type specifies what kind of value can be stored in a column. Null, not null is used to specify if we want to allow blank values. The keyword default is used to add a default value or for any column. Now let us understand the different type of different data types which we have in SQL. So the first is varchar. The first is char. So when we specify the data type as char, then in circular brackets we specify a natural number n. So char n is, and then n is the natural number, which is how long the data type will be, and its usage will be up to 255 characters. Char 5 specifies that a column can store a string of up to 5 characters. Now we'll understand all the data types after a short break.
जीवन ये प्रकाशित करने राहों को आलोकित करने,
जीवन ये प्रकाशित करने राहों को आलोकित करने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने, अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने, जीवन ये प्रकाशित करने राहों को आलोकित करने।
धन साधन समय की सीमा से विद्यालय जो मुक्त हो, धन साधन समय की सीमा से विद्यालय जो मुक्त हो,
कभी पढ़े हम कहीं पढ़े वे विषय की लोच से युक्त हो,
कभी पढ़े हम कहीं पढ़े वे विषय की लोच से युक्त हो,
मित्रों हम उठे और जागे,
मंजिल आने की ध्वनि सुने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने,
जीवन ये प्रकाशित करने राहों को आलोकित करने।
राष्ट्रीय मुक्त विद्यालय का है द्वार खुला सबकी खातिर, शिक्षा परीक्षा का अवसर एक बार ही क्यों मिलता फिर
शिक्षा परीक्षा का अवसर एक बार ही क्यों मिलता फिर दुनिया में इसके केंद्र बातें,
Yeah, so we discussed about the char data type. Now let's see varchar. So varchar is that it can be variable length. The char was for a fixed length, varchar can be of variable length, and the rest remains the same as char. Then integer, int is for the integer numbers. It can hold a very long value. If we talk about decimal, so with decimal we need to specify two attributes, m and d. So m is that how long the number would be, and d represents how many digits will come after the decimal. Suppose we are writing 64, then the number can be 6 digit long, and after the decimal there would be 4 digits. So it can be up from minus 99.9999 to 99.9999. Then the next data type is date. So date is used for storing dates, and it is widely used like for storing the date of joining, date of birth, etc. So now let us concentrate on creating a table. So let us create a table to store some information about the items sold at a local shop. So let us call that table as items. We are giving it a name, items. So to create the items table, we will give the following command: create table, then we are giving the name items, then in circular bracket we will be specifying that what all different attributes will be there. So we are giving an item code which will be of character type, then we are giving item distinct value, so which is a varchar, and we are also specifying it should not be null. Then we are also specifying CP, which is the cost price. Then we are giving 62, so it can be 6 digit long and 2 digits after decimal. Then selling price, same 62. Now you can view the structure of the table by using the command describe or desc. So you can write describe, the whole describe, or only desc, desc, and then the table name. This will give you the whole structure of the table. For example, the command disk item will display the structure of item table as follows. So this is the structure it will specify for the items table. The different fields, item code, item description, cost price, selling price, the data type, and then whether it can be null, whether it is a key, what is the default value, and anything extra. So the describe keyword describes the whole details of a particular table. Now to enter a row in a table, we use the command insert into. So we have to write the keyword insert into, then the table name, then we have to specify that now we are specifying values, so we have to write the keyword values and then the different values which we want to give. For example, to enter a record in the item table, we can use the command insert into items values, and then we can specify the different values. So A001 we are giving the ID, then curd 1 kg pack we are giving the description, and then we are specifying the cost price. Now the character and the varchar values are placed in double quotation marks. They also can be placed in single. So single and quotation, double quotation marks behave same in SQL. Numeric value can be integer and decimal. So let us now insert some more values in the item table. So we are giving the values as same as we have given before. Insert into items values, and then different set of values. We are giving 3 more rows to it. So now let's understand the select command. So select command is used to retrieve data from tables. In the simplest form, select command is used to retrieve complete data from a table. So we can just simply write select star from the table name. So this is going to return you the whole table. So whenever you have to use the select in the simplest form, you can just specify select and then star from and then the table name. For example, to view all the data from items table, we can use the command select star from items. So this is going to return you the whole details. If you want to view only specific columns of a table, you can specify the column names instead of the asterisk or the star which we used previously in the select command as follow. So select, and then in bracket, then you have to specify the column. So column name 1, column name 2, which all columns you want from table name. For example, to view only the item description and selling price of items, you can use the following command: select item description, comma, SP. Now also you have to focus that the SP which we used was in capitals and now we are using in lowercase. So both of these behave same in SQL. So select item description SP from items. So it is going to give you this table as the result. So now select command can also be used to display calculated fields. Earlier we were just, for example, to view the profit on each item, we use the command select item description SP minus CP. Now as you all know that profit is selling price minus cost price, so we can calculate the profit by giving simply SP minus CP. It is going to give you item desk and SP minus CP, 2 columns. Now select condition data can also be fetched by using the where clause. So when you have to filter your data, we can use the where clause. Suppose you want all the items which have their CP more than 30, then we will write select star from items where CP is greater than 30. So this is again going to give you the data in this format. We can specify more than one condition in where clause to get more specified data. Example, if we need to fetch the items whose CP is more than 30 but SP is less than 50, then we can write select star from items where CP is greater than 30 and SP is less than 50 and then a semicolon. Also we can merge any conditions using or and keywords, but we also need to use braces for the correct order of execution of the command. Now let us understand the distinct command. If we want to extract only unique values from any column, we can use distinct. For example, select distinct CP, SP from items. So this is going to return you all the different cost prices which we have given to the items table. To sort the output based on any column in ascending or descending order, we can use order by command. For example, select star from items, order by selling price, and if you want to have it in descending order, you can write DESC keyword, and by default the order will be displayed in ascending order. So how do we modify the structure of the SQL table? It is considered as data definition language as it alters the structure of an existing table, and it also has different variations according to the operation to be performed. To add a new column to your existing table or to remove a column, you use alter command. To add a new column, we can write alter table, then the table name, add, and then we can specify the new column which we want to add, and then again specify its data type and the other constraint which we want to apply. For example, to add profit column in the items table, you use the following command: alter table items, the name of the table, then add. We have to write this keyword add, and then we have to add the column profit. So in circular bracket we will write profit, and we will specify the data type as decimal. So the above command will add new column profit to the table items. To remove a column, we can use the keyword drop. So alter table items, drop profit. So the above command will drop the column profit. You can change the column definition by using alter command. So alter table item, modify item description varchar 30. Now this will modify the existing structure of the table. So in the above command, the column size of the column item description of a table item have been increased to 30 from 20. Now the update command. You can update your data values of the table by using the update command. So update table name, and then the set keyword is used, then we specify the field values. So update command is used to update either all or selected data values by using the where clause. One can update one or more fields of a same table under a single command by specifying the where clause, and it comes under data manipulation. Delete command. You can delete the data of a table by using delete command as follows. So delete from and then the table name, and if you want to apply a condition, then you can use the where clause with it. So delete command is used to remove rows from the table. It can be used to delete either all the rows or some selected rows. For example, If you want to delete something from items, you can delete from items, and if you want to specify a constraint, then you can write where cost price is greater than 40. Drop command. Drop command is used to remove the structure of a table from the memory. This is the difference between the delete and the drop command, that the drop command completely removes the structure of the table. Thank you so much. For more practice and information, you can regularly watch eVidya 12 for senior secondary program and visit our website for the course material.